This video is about solving quadratic equations. A quadratic equation is an equation that can be written in the standard form ax squared plus bx plus c equals 0. So a polynomial of degree 2, a quadratic polynomial, equals 0. There are different ways of solving quadratic equations. We can use the quadratic formula, we can use factoring, we can also use square root property, and I'm going to talk about these three different ways of solving quadratic equations in this video. With a quadratic equation like this, we call this quantity b squared minus 4ac delta, or the discriminant. And if your discriminant is greater than or equal to 0, then your quadratic equation has solutions, and the solutions are x1 and x2 minus b plus minus radical delta over 2a. So if you look at this formula, you can see that this formula only works if delta is something non-negative, because if delta is something negative, then radical delta is not a real number. And actually, if your delta is something negative, then your quadratic equation has no real solution. But if your delta is something non-negative, then you can use this formula to get the solution or the solutions. If delta is something positive, then you get one of the solutions with the positive one here. So you get x1, that is minus b plus radical delta, and you get x2, that is minus b minus radical delta over 2a. So you have two solutions. And if delta is something, and if delta is 0, then this part of the formula disappears, and you have only one solution, minus b over 2a. Okay, let's take a look at some examples. (5x squared minus 3x minus 2 equals 0). Okay, here you can see that a is 5, b is negative 3, and c is negative 2. I'm gonna calculate delta. Delta is negative 3 squared minus 4ac. This is 9 plus 40, giving me 49. Okay, so my discriminant is something positive. Since my discriminant is something positive, I know I have two solutions, and the solutions are x1 minus b, that is 3, plus radical 49 over 10, that's 2a, 2 times 5, 10. This gives me 3 plus 7 over 10, that's just 1. And x2, that is negative b, 3, minus radical 49 over 2a, that is 3 minus 7 over 10. This is negative 4 over 10, or negative 2 over 5. So as you can see, I have two solutions. Discriminant can also be 0. For example, in the quadratic equation 4x squared plus 12x plus 9 equals 0, a is 4, b is 12, and c is 9, The discriminant is 12 squared minus 4ac, and this is 144 minus 144 equals 0. And since the discriminant is 0, we have unique solution, and our unique solution would be minus b over 2a. In this case, minus 12 over 2a is 8, or negative 3 over 2. So notice that in the first example, delta was 49. And since 49 is a perfect square, we had two rational answers. Because if you look at the formula, let me write the formula again, negative b plus minus radical delta over 2a. If delta is a perfect square, then radical delta is an integer, and then minus b plus minus an integer is also an integer, so it would be an integer over an integer. That means we have two rational solutions. And if delta is 0, like in the second example, then we have only one. The formula becomes negative b over 2a. That means we have only one rational solution. Your delta can be positive, but it's also possible that it is not a perfect square. So for example, if I have x squared equals 4x minus 1, notice that this is not in the standard form, so I don't know what a, b, and c are. I have to write this in the standard form. X squared minus 4x plus 1 equals 0. I just moved these two terms to the left. Now if I calculate delta, I get negative 4 squared minus 4ac, that is 16 minus 4, which is 12. As soon as I know delta is something positive, I know I have two solutions. But since 12 is not a perfect square, I will have two irrational solutions. Let's see how. Minus b plus minus radical delta over 2a. Here it becomes 4 minus b plus minus radical 12 over 2a is just 2. Radical 12 can be written as 2 radical 3 over 2. So I know one of my solutions is, if I factor out the 2 from the numerator, I get 2 plus minus radical 3 over 2, and the 2 cancels the 2. So one of my solutions is 2 plus radical 3, the other one is 2 minus radical 3. So notice that here, because my delta is 12, which is not a perfect square, I ended up with two irrational solutions. Radical 3 is an irrational number. The sum of an irrational number and a rational number is an irrational number. So this number here is an irrational one. This is also an irrational one. Another thing that can happen is that you may get a negative delta. For example, x squared equals x minus 1. If I write this in standard form, I get x squared minus x plus 1 equals 0, and delta is minus 1 to the power of 2 minus 4ac, giving me 1 minus 4, or minus 3. This is a negative number. If delta is negative, then you know that the equation has no real solution. Since delta is negative, the equation has no real solution. Okay, so let's review the significance of delta in a quadratic equation. So don't forget that the quadratic equation is in the form ax squared plus bx plus c equals 0, and delta is b squared minus 4ac. So there are three things that can happen. Your delta can be something positive, your delta can be 0, and your delta can be negative, so less than 0. If delta is negative, then you know that you have no real solution. If your delta is 0, then you know you have unique solution. You have just one rational solution, and that rational solution is minus b over 2a. But if delta is positive, then again two things can happen. Your delta can be a perfect square. Is a perfect square. Delta is a perfect square. What is a perfect square? A perfect square is something like so positive and perfect square. 1, 4, 9, 16, 25, 36, and so on. These are perfect squares. Or delta is positive, but it is not a perfect square. If delta is a perfect square, then radical delta is a rational number, and then you end up with two rational solutions. But if delta is positive but it is not a perfect square, then radical delta is an irrational number, and you end up with two irrational solutions. Okay, so that's everything you can get from the delta. Delta can be positive and a perfect square. Then you will have two rational solutions. It can be positive but not a perfect square. Then you will have two irrational solutions. Delta can be 0. In that case, you will have one rational solution. And delta may be negative, and in that case, you have no real solution. Another technique that you can use for solving quadratic equations is called square root property. Square root property. Square root property says if x squared equals k, then x is plus minus radical k. For example, if x squared is 49, then x is plus minus radical 49, that is plus minus 7. So x is either 7 or negative 7, and that makes perfect sense. If x squared is 49, then x is either 7 or negative 7. So this is the square root property, and sometimes it's easier to use the square root property when you're solving a quadratic equation. For example, if I have 2x minus 1 squared minus 1 equals 5, since I have this x minus 1 squared here, First of all, let me tell you that you can use the quadratic equation here, but first you have to write this in a standard form. So you can expand this, you can raise this to power of 2, and then you can add up the like terms, bring everything to one side, write it in the standard form, and then use the quadratic formula. You can always do that. But another thing you can do here is to use the square root property. How do you use that? You modify this so that you have a square on one side and you have a number on the other side. So 2x minus 1 squared equals, if I move this -1 to the other side, becomes 6. And then if I divide both sides by 2, I get x minus 1 squared equals 3. Now you see I have a square on one side and I have a number on the other side. If x minus 1 squared is 3, then x minus 1 is either radical 3 or x minus 1 is negative radical 3. This one implies that x is 1 plus radical 3, and this one implies that x is 1 minus radical 3, and these are my two solutions. X is either 1 plus radical 3 or 1 minus radical 3. Let's look at another example. 2x plus 1 squared is 5. Okay, if 2x plus 1 squared is 5, then 2x plus 1 is either radical 5 or 2x plus 1 is minus radical 5. So this one implies that x is -1 plus radical 5 over 2, and this one implies that x is -1 minus radical 5 over 2. A squared plus 6a equals 3. Okay, if you have a quadratic equation like this, you may say, okay, now I have to move 3 to the other side so that I have the equation in the standard form, and then I'm going to use the quadratic formula, and you're absolutely right, you can always do that. But you can be creative at this point and you can make a perfect square on one side, because if you remember the formula a plus b squared, that gives me a squared plus 2ab plus b squared, yeah? So I can build this on one side of the equation. So if I add 9, I get to both sides, I get a squared plus 6a plus 9 equals 3 plus 9. Now you can see that this follows this formula. So if you factor this, this is a plus 3 to the power of 2. This is a squared plus 2 times 3 times a is 6a plus 3 squared, that's 9, equals 12. Now you can use the zero factor property, the square root property, and you know a plus 3 is either radical 12 or a plus 3 is minus radical 12. So it's either 2 radical 3 or minus 2 radical 3. This implies that a is either -3 plus 2 radical 3 or -3 minus 2 radical 3. Okay, so this is the square root property. For this problem, you can see that it was really easy to use the square root property, but for this one here, actually it doesn't give you an advantage to use the square root property. You can always use the quadratic formula for this one. So with your quadratic equation, if your delta is a perfect square, if it is 0, 1, 4, 9, 16, 25, 36, and so on, if it is a perfect square, then you can also use factoring in order to solve the quadratic equation. Don't forget that you can only use factoring, and actually these quadratic equations are only factorable over integers if your delta is a perfect square. And then if your delta is a perfect square, you can use the zero factor property to solve the equation. What is the zero factor property? Zero factor property. Zero factor property says if AB equals 0, then either A is 0 or B is 0. So that's the zero factor property. If I have the product of two factors, A and B, and that's 0, then either A is 0 or B is 0, or both of them are 0. This is the zero factor property. Now, how do we use that in order to solve quadratic equations? X squared minus 2x minus 3 equals 0. Let's check delta. Delta is negative 2 squared minus 4ac. This is minus 2 squared minus 4ac. Yeah, that gives me 4 plus 12, that is 16. Okay, 16 is a perfect square. So at this point I know that I can solve this by factoring. Now let's factor this. If I factor this, I get x minus 3 and x plus 1 as the two factors, because negative 3 and 1, if you add them up, you get negative 2. If you multiply them, you get negative 3. So this times this is 0. This is only possible if either this is 0 or this one is 0. So either x minus 3 is 0 or x plus 1 is 0. The first one implies that x is 3, and the second one implies that x is negative 1. So I have two solutions, 3 and negative 1. Could I solve this using the quadratic formula? Of course. The quadratic formula says the solutions are negative b plus minus delta over 2a. And in this problem it would be 2 plus minus radical 16 is 4 over 2a, or 2. That would give me the same solutions. 2 plus 4, 6 over 2, 3, and 2 minus 4 minus 2 minus 2 over 2 minus 1. That would also give me the same solutions. So for this problem, you can either use quadratic formula or factoring. Let's look at another example. 3x squared equals 5x minus 2. First I write this in the standard form, 3x squared minus 5x plus 2 equals 0. Let's check what delta is. Delta is minus 5 to the power of 2 minus 4ac. That gives me 25 minus 24, 1. So 1 is a perfect square, so I can use factoring in order to solve this problem. in order to factor this, I need to ask myself, I'm looking for two numbers a and b, so that the product of ab is 2 times 3, 6, and the sum is -5, and the two numbers are -2 and -3, because the sum would be -5 and the product would be 2 times 3, 6. So I write the polynomial as 3x squared minus 3x minus 2x plus 2, and then I use factoring by grouping. 3x, x minus 1 minus 2, x minus 1 equals 0. So x minus 1 is a common factor. 3x minus 2 equals 0. At this point, I use the zero factor property. Either this factor is 0, which implies that x is 1, or this other factor is 0, which implies that x is 2 over 3. Could I use the quadratic formula, negative b plus minus delta over 2a? Of course, this would give me 5 plus minus radical 1 is 1 over 6. 2a is 6. The plus would give me 1, the minus would give me 4 over 6, which is 2 over 3. Same solutions. Okay, now let me give you an example where you can only use factoring, because this is actually not a quadratic equation. 2x to the power of 3 minus x to the power of 2 equals 8x minus 4. In this equation, you cannot use the quadratic equation because this is not the quadratic equation. This is a cubic equation. You can see the highest power is 3. If I write this in the standard form, I have 2x to the power of 3 minus x to the power of 2 minus 8x minus 4 equals 0. I have a polynomial in descending order of powers in a standard form, and you can see the highest power is 3, so this is not a quadratic equation, and you have to use factoring at this point. If I group these two and these two, I can factor this polynomial. I can factor out 1x squared from the first group, get 2x minus 1. I can factor out a -2 from the second group. I get -2. -2 times 2x is 8x. That's good. Minus 2. I need to factor out a -4. Sorry, -4 from the second group, and then -4 times 2x is -8x, and then minus 1. That's good. Now I factor out, I see the common factor is 2x minus 1, x squared minus 4 equals 0. Okay, let me check that. I factor out -4. That's good. I use the zero factor property. In order for this equation to work, either this is 0 or this other factor is 0. Two x minus 1 being 0 implies that x is 1 over 2, and x squared minus 4 is 0 implies that x squared is 4. This implies that x is either 2 or x is -2. Here I'm using the square root property. So x is plus minus radical 4, that's plus minus 2. So I have three solutions, 1 over 2, 2 and negative 2. So for this problem you had to use factoring. Not all cubic equations are factorable, but this one was, and we were able to use factoring in order to solve the equation. Okay, and that's it for solving quadratic equations.